We're talking about volume here. It's approximately yes, cm cube. That's for the volume, the new volume that we have. So let's go over to the next question. I mean, well, if you are joining us for the first time, we want to encourage you to subscribe and then like. If you have any question based on what we have done so far, you can leave it in the comment section. We can always attend to you anytime. All right. All right, let's continue. The next question here says that a gas occupies 400 cm cube at 510 millimeter mercury if the temperature remains constant. If the temperature remains constant, what will be the pressure? What will its pressure be when the volume is reduced to 262 cm cube? So I think we can also go by this. The first pressure there, the pressure, our volume in this case, the volume here is a, the V1 is the 400 cm cube, and the pressure there. Hello everyone, today we'll be looking at um, Boyle's law. Now, Boyle's law is one of the gas laws that help us to understand the behavior of gases. Now, according to Boyle's law, it says that the Boyle's law says that a volume of a fixed mass of gas is inversely proportional to its pressure, provided that the temperature remains constant. So as long as the temperature remains constant, the volume is inversely proportional to pressure. So if we're going to be looking at it mathematically, what it simply means is that volume is inversely proportional to pressure, which means if the volume increase, pressure will decrease. If pressure increase, volume will what? Decrease. That's just what we mean by inversely proportional. Now, if we are to go further in mathematical representation of this, that by applying a constant, that is, if we apply a constant, volume will then be K over P, where K is equal to what? Constant. This constant, that's what we mean. Now to get this constant simply means, since we know that volume is equal to K over P, then to get the value of K, that's the constant, will then be K will be equal to V over V multiply P. So in a case where you're comparing, let's say you're comparing two gases, the constant remain the same. In that case, what it means is that V1 is equal to what? V2 and V2, since the constant remains the same. So this is what we have. For example, now if you want to get the value of each of, let's say as we're comparing two gases here, that to get the value of any of these two gases, that V1 and V2, we can also make that possible. So let's just look at some calculations that will help us truly understand it very well. So here we have questions that will help us understand this Boyle's law very well, so that we'll be able to know how to apply it. Perhaps if we see it in exam, how to get each of the values given to us. The first question says 100 cm cube, 400 cm cube of a gas has a pressure of 7 70 millimeter mercury. Find its volume if the pressure is reduced to 7 740 millimeter mercury. So now, if you look at this more like comparing the two gases in order to get what we are looking for. And we know that the constant remains the same. From that, and we know that um, from what we have already stated, we find out that V1 V1 is equal to V2 V2. So that's what we have. In this case, our V1 here, our V1, that's the volume 1, will be 400, is 400 cm cube. And then our P1, this is the pressure here. P1 is equal to 770 millimeter mercury. That is what we have. So we say that find its volume. Now we are given the pressure, the P2, which is 740 millimeter mercury. Now we don't have the volume. The volume is what? Unknown. We are going to get this volume. So with this formula we have here, with this formula we have, what we are going to do now is to substitute. We are substituting everything we have here in order to get the V2. So what am I going to do here? The V1 here is 400, and then we have our P1, which is 770, is equal to V2 times our P2, which is 740. So if we divide both sides by 740, divide both sides by 740, this will go, and 740 dividing this other end. So it will give us, we mean that our V2 will be, let me just go through it here, this calculator. We have a 400 times 770 divided by 740. What we have here is, what we have will be approximately 4116. Since we are talking about volume here, it's approximately, yes, cm cube. That's for the volume, the new volume that we have. So let's go over to the next question. And meanwhile, if you are joining us for the first time, we want to encourage you to subscribe, and then like, if you have any question based on what we have done so far, you can leave it in the comment section. We can always attend to you anytime. All right, let's continue. The next question here says that a gas occupies 400 cm cube at 510 millimeter mercury if the temperature remains constant. If the temperature remains constant, what will be the pressure? What will its pressure be when the volume is reduced to 262 cm cube? So I think we can also go by this. The first pressure there, the pressure, our volume in this case, the volume here is still, the V1 is still 400 cm cube, and the pressure there, the P1 is what? Millimeter mercury. And now the next volume, the V2, is now 262 cm cube. Now in this case, we are looking for the volume, the pressure. Pressure is unknown. Substituting each of them, we have 400 times 510 is equal to what? 262 times now V2. So if we divide everywhere, both sides by 262, this will go, then 262 dividing here. So what we have again will be 400 multiplied by 510 divided by 262. We have we have we have the pressure will be 7 approximately, that's approximately 9 millimeter mercury. 7.779 millimeter mercury. That's the final answer. All right, thank you so much for being part of the class, and we want to hear from you via the comment section. If you're joining us, I will encourage you to subscribe and like. Thank you.